Hello, today we're going to talk about Spearman's rank correlation coefficient. So there are times when a linear model may not seem appropriate for the dataset based off how the scatter plot looks. Whenever this happens, it may be best to look at the directional trend of the data, meaning is it increasing or going in a positive direction, or is it decreasing or going in a negative direction? So in order to do this, we do it by looking at what we call the Spearman's rank correlation coefficient of a dataset, which is nothing but the Pearson's product moment correlation coefficient of the variable's ranks. This is the relationship between each variable's ranks instead of the raw values. So when choosing the ranks for each data value, you must go in the same order for both variables. So you must rank your numbers from either least to greatest or from greatest to least. So let's look at an example here. So example 1, it says the following data shows the annual income per head of population X in US dollars and the infant mortality Y per thousand live births for a sample of 11 countries. So X represents the US dollars and then Y represents the infant mortality rates. So it says use technology to create a scatter plot for the data. So I'm going to press stat edit and I'm going to type in my data into L1 and L2. Making sure that you are very careful with what you're typing in. All right, so I have my values for L1 typed in. Now I'm going to put in my values for L2. All right, so now that I have my values in, I'm going to create a scatter plot. So I have to press second Y equals, and I'm going to turn my plot 1 on, and I'm going to make sure that it's set on scatter plot. And then I'm going to press zoom 9 for zoom stat. And here's my scatter plot here. So as you can see here, I can tell that there is a negative trend, okay? But it doesn't necessarily look like a line. This kind of looks like a curve, which means it's leading me to think that it may be exponential. So the fact is that it does not look linear. So what we want to do in part B, it says that they want us to calculate Pearson's product moment correlation coefficient for this data. So I'm going to first go to mode and I'm going to turn my stat diagnostics on. And when I turn my stat diagnostics on, I'm going to press stat, go over to calc and go to number 4, ln reg ax plus b, and then I'm going to press enter. So now I see that my Pearson's product moment correlation coefficient is approximately negative 0.739. So this is a moderate negative relationship or a moderate negative linear relationship. Remember that Pearson's correlation coefficient, you're trying to find the strength and the direction of a linear relationship. So Pearson is only dealing with linear relationships. So for part C, it says find the ranks for each variable and use technology to draw a scatter diagram of the ranks. So I'm going to rank my numbers from least to greatest. So I see that 130 is going to be ranked as 1. It's going to be the first number in my list. Then I know that 170 is going to be the second number in the list. Then I know that 390 is going to be the third one, which is data point G. The X value of data point C is going to be the fourth one. Then you're going to have data point H, which is going to be the fifth one. Data point I is the sixth one. Data point E is the seventh one. Data point D is the eighth one. Data point K is the ninth one. Data point B is the 10th one. And data point J is going to be the 11th ranking. So I have ranked my numbers from least to greatest from 1 to 11 for the X values. I need to do the same thing for the Y values. Okay, so when I rank my Y values from least to greatest, data point J is going to have the smallest Y value. Then data point K is going to be the next one. Data point E is going to be the third one. Data point B is the fourth one. Data point D is the fifth one. Data point H is the sixth one. Data point I is the seventh one. Data point C is the eighth one. Data point G is the ninth one. Data point A is the 10th one. And then data point F is the 11th one. So literally all I did was I just ranked my numbers from least to greatest, okay, for the X and the Y's. So now I want to draw a scatter diagram for that. So I'm going to clear out my original list. And now I'm going to input the rankings. So I have 1, 10, 4, 8, 7, 2, 3, 5, 6, 11, 9. Then I'm going to do the same thing for the rankings of my Y values: 10, 4, 8, 5, 3, 11, 9, 6, 7, 1, and 2. All right, so now that I have my rankings in there, I'm going to draw my scatter plot. So once again, we've already turned the scatter plot on, so we don't have to repeat that step, because once it's on unless you clear your calculator or reset your calculator. So we can just press zoom 9. And now, as we can see here, we see that there is a negative trend in the data. Remember, when you're dealing with Spearman's rank correlation coefficient, you are only focused on the direction. You are not assuming that anything is linear. That is specifically Pearson's, okay? Remember, Pearson's corresponds to linear relationships, and it tells you the direction and the strength of a linear relationship. Spearman's only concern is the direction, whether it's increasing or decreasing, being positive or negative. So now that we have the scatter plot, we can clearly see that the trend is negative, and we want to calculate the Spearman's rank correlation coefficient for part D. So in order to do that, I'm going to press stat, go over to calc number 4, and I'm going to press calculate. So now the R value for the rankings, which is R sub S, is approximately negative 0.3936. So that is my Spearman's rank correlation coefficient. So it says here, which correlation coefficient is more appropriate to use for the data and why? So as you can see here, the one that is stronger is the Spearman's correlation coefficient. So I would say that we would use R sub S because it is stronger. So Spearman's is stronger. So now it says describe the correlation between the variables. So I can basically say that the annual income and the infant mortality have a strong negative relationship. We don't care about if it's linear or not. Now, that if negative 0.936, if that was the Pearson's correlation coefficient, then we would say it has a strong negative linear relationship. But we're not talking about Pearson's, we're talking about Spearman. So we're only talking about the strength of the positive or the negative relationship, no matter if it's linear or not. All right, so now let's look at what happens whenever we have ranks of tied values. So in some cases, you may have X or Y values that are tied, meaning that they have equal values. Tied values must be given the same rank. Okay. When this happens, we assign the average of the rankings. So I like to tell my students, you want to rank all of your numbers up and then go back and then calculate the average of the ones that are the same. All right. So the example below, it says, the table below shows the systolic and diastolic blood pressure values of 12 patients. Calculate Spearman's rank correlation coefficient, R sub S, for this data. So in order to do that, we need to rank our values for the X and the Y's. So for my X values and my Y values, this time I'm going to show you that you can do it by going from greatest to least, okay? So I'm going to look at the biggest number in this case. So the biggest number that I see for my X values is 140. So I don't know which order it is because I see more than 140. So I don't know which order it is, but I'm just going to do it from left to right. So I'm going to assume that this is going to be rank 1, 2, 3, and 4. And I'm going to highlight this to indicate that they should have the same value, okay? Because remember, we have to find the average of the ranks. The next biggest number that I see is going to be, or the next smallest number to 140 is going to be 135. So I'm going to say that that is rank 5. And then we have rank 6 being 130. Then we have rank 7 and rank 8 as 128. And then we have rank 9 as 124, rank 10 as 120, rank 11 is also 120, and then we have rank 12 here as 118. All right. So when I look here, I remember seeing that we have 128 twice. So I'm going to highlight those numbers. And then we also have 120 as well twice between 10 and 11. So I need to find the average of these values. So I'm going to start off with 1, 2, 3, and 4. So for 1, 2, 3, and 4, if I find the average, 1 plus 2 plus 3 plus 4, and I'll divide it by 4 numbers, I see that they should have the value of 2.5. All right. Next, I have the rank 7 and 8. So with my rank 7 and 8, if I find my average, 7 plus 8 divided by 2, I end up getting 7.5. And then I do my rankings for 10 and 11. So I have 10 plus 11 divided by 2, which is 10 and a half. So I'm going to have 10.5 here. All right. So next, what I do is I do the same thing for my Y values. And remember, I'm going from greatest to least. So 75 would be my greatest number. Here, excuse me, and it's not 75, it's 94, excuse me. 94 is my greatest number here. And then 90 is going to be the second largest number. And then we're going to have 85, which is the third largest number. Then we're going to end up having 80 as the fourth largest number. And as you can see, I see 83 times. So that is going to be 4, 5, and 6. And remember, we don't know the order that they're supposed to be in. So that's why we're going to take the average. And then we have 75 as rank 7. Then we have 70 as rank 8. Then we have 68 as rank 9. And then we end up having 60 3 times, which is rank 10, 11, and 12. Okay, so I'm going to highlight the ones that were the same, like I did before. So I have 10, 11, and 12. They were the same numbers. I ended up having 80 for 6, 5, and 4 for those. And I should not have anything else that is the same. So now we can start calculating our averages. So we're going to have 4 plus 5 plus 6 divided by 3. So that means that our average there is 5. So these rankings are all going to be 5. And then for 10, 11, and 12, 10 plus 11 plus 12 divided by 3 is 11. So here we're going to have our rankings as 11 here. All right. So now, in order to find our Spearman's rank correlation coefficient, we're going to go to stat edit. We're going to clear out everything that we have in L1 and L2, and we're going to type in our rankings. So we have 10.5, 12, 6, 2.5, 2.5, 7.5, 2.5, 2.5, 10.5, 7.5, 9, and 5. For L2, we have 11, 9, we have 11 twice, and then 9, 2, 5, 7, 1, 5, 11, 5, 8, and 3. So now that we have these values in the calculator, what we are going to do now is that we're going to go to stat, go over to calc, number 4, go down to calculate, and we end up seeing that R sub S is equal to, or is approximately, 0.866. So this is our Spearman's rank correlation coefficient. So this is telling us that we have a strong positive relationship. Remember, it does not have to be linear or non-linear. It does not matter. We're only focused on the direction. This is not Pearson's. So if you have any questions on Spearman's rank correlation coefficient, please let me know and have a great day.